Good afternoon. Hi everyone. Thanks for joining our session. My name's Gary Strange. I'm a lead data engineer for ASOS. Here with my colleague, Andrew Potts.
Hi, I'm Andy Potts. I'm an architect at ASOS.
We've travelled over from London, England to share some insights with you about how we build and design systems for large-scale sale events like Black Friday. I'm going to tell you a little bit about how we meet our data challenges, and Andrew's going to share some insights about our compute strategy.
So, who are ASOS? ASOS are an e-commerce fashion retailer with a goal to be the #1 fashion destination for 20-somethings. We've got no physical stores. We engage with our customers through our website, through our native mobile apps, and through social media. We were formed in the year 2000, and we've been growing steadily ever since, with about 30% year-on-year growth. We deliver now to over 200 countries. We take orders from all around the world. We've got fulfillment centres in the UK, in Europe, and we're now opening up new ones in the US as well.
So, we have two technology problems that are really nice to have. The first, ASOS is growing at an incredible rate. Our revenues increased by 30% year on year. And the second problem is we have these very large-scale sale events like Black Friday. During an average week, we process around £90 million worth of orders. During Black Friday, we processed 288 million in just 4 days. Now, if we compare the peak hour on a Black Friday sale event to an average hour, there's a 6x jump in demand on our platform. So our scaling issues are twofold: aggressive year-on-year growth and large-scale sale events. And on top of that, we aim to deliver a first-in-class online shopping experience for our customers. So we have some significant business challenges. We need technologies and services that are performant, resilient, highly available, and scalable. We can't afford to stand still. We're always looking ahead. By the year 2021, we estimate that our order rates will have increased by 235%. So we need to stay ahead by utilising technologies that are easy to manage, they can scale both horizontally and vertically, and offer high availability natively. So how do we implement data persistence? Our platform is made up of many microservices that communicate with each other. Each microservice is deployed in multiple regions. This architecture delivers high availability and redundancy. We use Cosmos DB for our data persistence. With Cosmos DB, geo-replication is easily configured and allows us to scale data globally. So our customers get the benefit of low latency reads wherever they are shopping in the world. And if you caught the keynote yesterday, the Cosmos DB product team actually announced that now they've got multi-master writes. So we'll be adapting that, and our customers will also get the benefit of low latency writes wherever they are in the world. Geo-replicating our data also allows us to perform regional failovers to hot secondary regions in the event of network partitions or a regional incident. These architectural attributes give us the foundation to produce gold-tier services with 4.9 SLAs. As Cosmos DB is a natively partitioned database, the upper bounds of storage and compute are unleashed. We don't have to be concerned. We don't have to be too concerned about hitting our limits. There's no longer a need to do our own infrastructure capacity planning. That's now Microsoft's problem, and we love that. Nor do we have to be concerned with provisioning or migrating systems to larger instances. Again, that's now Microsoft's problem, as they scale partitions seamlessly behind the scenes. There's no interruption to service during partition splits. This is important for us. We want to deliver a first-in-class shopping experience for our customers. We don't want them to be in the middle of a purchasing journey and there to be an interruption to service and then to leave our site. There's no longer a need for us to worry about long and lengthy change requests with backup plans, etc., just to increase storage or compute limits. This allows us to concentrate on developing business value and new innovations for our customer. Scaling request units. For those of you that are not familiar with request units, are you? It's a logical consumption charge. It's based on CPU, memory, and I/O used during a transaction. Using our historical transaction data, we estimate baseline throughput required for day-to-day trading. We use these estimates to provision Cosmos DB accounts with enough RU, and RU is fairly granular, so we can be quite specific per microservice. Now, I'll just explain the chart. This is a 24-hour trading period. The grey line at the bottom is an average 24-hour trading period. We start to get busy around morning time, people waking up, doing a little bit of shopping, get a little busier in the evening, and we tail off as night draws in. Now, if we take a look at the pink line, that's what happens on first day of Black Friday. A huge jump in demand on our system, so we need to be able to cope with that. So, ahead of large sales like this, we scale up our Cosmos DB accounts to cope with the additional load. Once the sales period is complete, we scale them back down again for economy throughout the rest of the year. Now, I'm going to hand you over to my colleague, Andy Potts. He's going to tell you a little bit more about how Cosmos DB fits into our compute strategy.
Thanks, Gary. Hi, everybody. So I'm going to talk to you about one of our use cases within ASOS, which is processing orders and returns, and how the Cosmos DB Changefeed processor fits into that story. So this is a typical workflow we might have in ASOS. This is booking a return. So the idea being, as a customer, you've taken some products home, you've tried 3 or 4 out, you want to send 2 of them back to ASOS. Traditionally in the past, you'd have had to put them in a parcel and send them back to ASOS, and we wouldn't refund you until it's arrived at the warehouse. We want to improve that shopping journey. So the idea being here, you can book your return online. As soon as the courier scans the parcel, you get your money back. So we have a workflow built up here. We build it up as a set of microservices. Here we're showing that when you've booked the return online, we save it in the portal. We then validate that request. We then book a collection with the courier. And then once they've done that, we can then generate a return label and send it down to you to put onto the parcel. We've built this up as a set of microservices with events flowing in between them. So in the past, we might have used something like Azure Service Bus to send messages between the services. But with Cosmos DB, we can use the Changefeed processor. And I don't know if you went to the session this morning. We had a session this morning where they went through that and they were using Azure functions. If we look at a typical handler, let's step into one of the handlers. This is the document generation. When a collection's booked, we get an event, and then we call a third-party API, download a PDF, send it to blob storage, and then we issue a document created event. If we look at the code, all we do here, first of all, is we load the original events from an event store. So we're using an event sourcing pattern. That gives us an immutable audit log of everything we've done to that return. So we load the previous events back into the aggregate, rehydrate the state, and then we do our unit of work, which is in this case building up a PDF, saving it to blob storage. And then we publish an event. So you can see it's very small, very lightweight, very easy to test and deploy. It would be suitable for things like Azure Functions, or you might choose to use AKS or Service Fabric. The great thing about the Cosmos DB Changefeed is that it supports .NET Core, so you have a whole range of portability options into how to deploy and use this. Now, traditionally, we used cloud services to host these, but they would have been very low density, very expensive, very slow to deploy. You know, that 5 lines of code over 3 worker roles in 2 regions suddenly gets very expensive. So we've looked at other options and how we might host this. So just to show you the Changefeed processor in action, we can then, using the Changefeed, as we save the order or save the return into the returns database, we can then listen to the Changefeed of that Cosmos DB collection. The validation service can then pick it up, then the collection service, and so on and so forth. So we're choreographing these events together and building up a workflow. But each service is small, autonomous, easy to deploy, easy to scale. So all of this is working on Cosmos DB's Changefeed processor. So what happens with Cosmos DB is when you save a document, it goes into one of the partitions based on the partition key. Here I'm using order reference. And my example here is showing 3 partitions. So I save that document, it goes into one of those partitions, it gets replicated around the replica set, and then down at the bottom here, we've got a logical service processing those changes. So every time we write a change into Cosmos DB, it gets assigned an LSN, a logical sequence number, and that's your record, your transactional record of the save. This processor here can use the Cosmos DB SQL SDK and enumerate those partitions and enumerate the changes in those partitions. So you can say, give me the last change since LSN4, and it will give you a list of changes that have occurred. And using that, we can build up our event-driven architecture. So what I showed previously is one logical process, one physical process, enumerating those 3 partitions, but for scalability and increased performance, you can then scale it out to 1 or more processes, up to effectively 1 process per partition. That gives you much greater parallelism. So we're going to do a demo now just to show you how this all works. This demo is now going to be based on booking an order. So we're going to have a client, a web API, a web checkout, placing an order with the order API. We're then going to set up a service that listens to those orders as they're saved and handles those changes, and we're going to host it in AKS. So if you could switch. So let's have a look at the code we need to write. So Microsoft provide a Changefeed library, which I recommend using. It takes a lot of abstraction away from you. And effectively, you need to implement the iChangefeed observer interface. There are 3 methods on it. Open async, that's called whenever the service acquires a lease. So the idea being you can have multiple processes competing to process that partition. So this gets called whenever you gain the right to process a partition. You have close async, which is whenever you lose that right. That might be because you're shutting down your service or because another one's been started up and he's stolen the lease from you. And the most important method here is process changes. This is called in a polling loop. You can configure how many documents are retrieved, how frequently, but it gets called and you get passed an enumerable list of documents. These are the documents that have changed since your last LSN that you've asked for. And then all I'm going to do is enumerate those documents. I'm going to cast them into orders. That was my original POCO that I had representing the order. And then I'm going to log out the processing time and the order reference. Now, in a real-world example, you'd probably do some work at that point. You might call a third-party API to bill the customer, to validate the order, all these sorts of things. And then you might save an event back to Cosmos DB or publish an ASB message. So I've built this in .NET Core because the Changefeed process supports .NET Core, and .NET Core gives me all these options in terms of hosting. That's right, no. Yeah. That's right. So once I've built my project, I want to go and now run this in AKS and Kubernetes. So first thing I need is a Docker file. This is a typical Docker file. It's very simple to build it. What I like about the Changefeed processor, as I said, it runs in .NET Core. So with a few character changes there, I can now build that for Linux, or my example here is Linux 32. So I can now run that on a Raspberry Pi if I want to, which personally I love. Not suggesting we run our production code on Raspberry Pis, but it's a nice option to have. We then deploy to the Azure Container Registry with a few lines of PowerShell. One thing I realized doing this is you need to create a service principal, otherwise AKS cannot pull your image down from your container registry. And then a Kubernetes deployment spec. I've referenced at the bottom the Azure secret. That's my credentials that I need to pull the image down. And I've put a replica set in there. The definition is just one pod at the moment. I've done that just to make the demo a little bit easier, but then I'll show it scaled out at the end. So let's have a look at that. So if I go, so I've deployed this to a AKS server running in central US. So if I do kube control get deployments, there we go. We can see I've got my deployment with a pod count of 1, just to show that a bit more in detail. There we go. So what I'm going to do now is I've got a demo checkout here. So I'm going to place a couple of orders. I'll just place one for now. So that order reference ends in LT9. So if I go across back to here and look at my logs, so you can see here the Changefeed process is running, and okay, I'm still running in UK time there, so apologies for that, but it's picked up the order. So if I quickly show you just how quickly the Changefeed processor works. There we go. He's picked up the new order. So it's just sitting there listening to orders as they're coming in and then processing them. So that's running with a replica set of 1. What you can now do is very quickly scale that out. So I've got 5 partitions in this Cosmos DB, but for simplicity, I'll just up it to 3. Okay, so you can see the containers being created there. 2 are done. 3 are done. So the great thing about .NET Core, it's running Linux containers, very fast to start up, and immediately scaled out to 3. So what I'll do now is just place a couple more orders. W9 and WD. If I look back at my log for the original one, down here you can see he's closed a worker. That's because one of the new pods has now stolen the right to process that partition. So he's relinquished the processing. Previously he was listening to changes in all 5 partitions. Now he's let go of one of them. And just to show you, here's one of the new ones. So you can see here he's opened up the right to process 2 partitions. Unfortunately, he's not done any work, so I'll just go to this last one here. And he's picked up the last order. So that just goes to show you really that the Changefeed processor written in .NET Core, you can host it in a multiple of options. Here I've chosen AKS and I've scaled it out. So what I like about the Changefeed processor, it helps avoid transactions. I can just do work, save work to a database, and then process off the back of it. It's suitable for hosting with a variety of hosting models. And another thing is, using .NET Core, you can use the .NET templating, where basically you set up an example processor, and then you can just use the substitution parameters to rename the service name, rename the contracts it listens to, substitute in the auth keys for Cosmos DB. So the goal really being is you want to be able to build and deploy in a day.
Thanks, Andy. Great demo. We're almost at the end now. We are hiring like everyone else is these days, but we really are hiring very aggressively. We get 30 new people, 30 new starters each week at ASOS. And please feel free to get in contact with us. Contact details are up there, and also we have the GitHub repository available. Just to know, LinkedIn recently published a report on the best UK companies to work for in the UK, and who was number 1? Oh, ASOS was number 1. Okay, thanks everyone.
Thank you very much.